Forget the diesel workhorses. Today we return to the golden age of rail, when engineers defied every limit of physics and scale. We are not talking about quaint old trains. We are talking about industrial monsters, the largest steam locomotives ever built. These colossal machines unleashed extraordinary power to conquer the world's toughest rail lines. From the massive American Union Pacific Big Boy to the equally fierce Allegheny, we are going to examine exactly which machine truly deserves the crown of power. Subscribe and comment now to join the debate. Let's begin this countdown. The name itself is legendary, Big Boy. This locomotive doesn't just represent American railroading, it defines it. When the Union Pacific needed a solution to haul heavy freight trains over the steep grades of the Wasatch Mountains, they didn't ask for a bigger train, they asked for a monster. And they got the 4884 articulated masterpiece. The Big Boy's colossal scale was a direct response to a massive economic demand. Designed in the 1940s, it boasts an incredible 6,290 horsepower and a total weight, with tender of nearly 668 short tons. Its 4884 wheel arrangement means it had 8 driving axles, a massive footprint to generate the necessary grip. The secret to its efficiency was its articulated design, allowing the front engine to pivot independently, enabling it to navigate curves while delivering unprecedented power. This massive machine could maintain high speeds while climbing steep gradients, a feat few other locomotives in the world could match. Its maximum tractive effort was an overwhelming 135,075 pounds-force. Only 25 of these magnificent machines were ever built, and their service life, though relatively short due to the rise of the diesel engine, was utterly transformative. They streamlined freight operations, reduced the need for helper engines, and symbolized the zenith of American steam power. Today, the surviving Big Boys, particularly the operational number 4014, draw millions of spectators, confirming their status not just as historical artifacts, but as enduring icons of pure, unstoppable American muscle. If Big Boy was the undisputed heavyweight champion, the Chesapeake and Ohio H8 Allegheny was the hidden contender, often cited as the most powerful steam locomotive ever constructed, challenging the Big Boy's sheer size. Built primarily to haul massive coal trains across the treacherous Appalachian terrain, the Allegheny needed brute force, not just speed. The H8, with its 2666 wheel arrangement, featured a massive expansive firebox that was necessary to generate steam at the required rate for continuous high-output performance. This locomotive generated an astounding 7,500 indicated horsepower, comfortably eclipsing the Big Boy. Crucially, its maximum recorded tractive effort stood slightly higher than the Big Boy's, officially reaching a staggering 141,600 pounds-force, making it arguably the strongest locomotive on paper. Its design was unique because of the 6-wheel trailing truck beneath the firebox, necessary to support the gargantuan weight of the boiler and firebox assembly, which was essential for generating that record-breaking power. The Allegheny's career was defined by relentless work in the heart of the coal industry. Operating on tight, winding mountain lines, their incredible power allowed for much longer, heavier trains than previously possible. While fewer were built than the Big Boys, their impact on coal logistics was profound. The debate over which locomotive was truly the largest often comes down to definition. Big Boy had the greater physical length, but the Allegheny possessed a superior power output, making it the king in the critical metric of raw strength. Shifting our focus across the globe, we encounter the Russian-class P-36, a locomotive that perfectly encapsulated the post-war ambition of the Soviet railway network. While not designed for the extreme tractive effort of the American giants, the P-36 was built for high-speed, long-distance passenger service across the vast, often demanding landscape of the USSR. Its large size was dictated by the sheer scale of the distances it had to cover. The P-36 was nicknamed General and immediately stood out due to its impressive, almost streamlined appearance and the iconic red stars decorating its front. Mechanically, it featured the classic 484 wheel arrangement, a configuration highly favored globally for high-speed passenger engines, providing both stability and power. It was the last large passenger steam locomotive designed in the USSR. Its sheer physical size, required to accommodate a large boiler and firebox for continuous speed, made it one of the largest passenger steam locomotives ever built outside of North America, capable of running up to 78 mph. These engines were the pride of the Soviet railway system, primarily operating on the flagship Moscow to Vladivostok route. They were designed for endurance and comfort, ensuring rapid transit across multiple time zones. With an operational weight of approximately 170 short tons for the engine alone, their imposing size and distinctive aesthetics serve as a reminder of the era when passenger travel across the vast Russian landscape was synonymous with the power of steam. The South Africa Class 25NC may not have the headline-grabbing tractive effort of the American articulated types, but its size and efficiency were dictated by one crucial factor: endurance over arid distances. Built to operate across the long, water-scarce lines of South Africa, the 25NC was an incredible engineering feat focused on operational self-sufficiency. This locomotive was a conventional, non-articulated 484 design, but its size was maximized for its unique operational environment. The most distinctive feature was the massive fully enclosed condensing tender. In South Africa's dry climate, water conservation was paramount. The condensing system allowed the steam to be recirculated and condensed back into water, significantly extending the operating range between water stops. This tender was enormous, contributing significantly to the locomotive's overall impressive length of over 111 feet and total weight of approximately 259 short tons, making it a truly large machine designed for massive self-reliance. The Class 25NC were the workhorses of the long-distance freight and passenger lines, especially the route from DR to Kimberley. Their condensing apparatus proved highly effective, allowing them to cover vast, often isolated areas with minimal support. While many were later converted to non-condensing NC versions, the original Class 25NC stands as a testament to specialized engineering. Its size was functional, a massive mobile ecosystem designed to conquer the environmental challenges of the African interior. The Pennsylvania Railroad Q2 represents one of the final massive attempts by the PRR, known for its standardized but highly effective designs, to build a dual-purpose locomotive, powerful enough for heavy freight but fast enough for time-sensitive movements. This locomotive, built during the heart of World War II, was an enormous rigid-frame beast, maximizing power without articulation. The Q2 featured the impressive 4464 wheel arrangement, a unique configuration that employed a massive six-coupled set of driving wheels. It generated incredible tractive effort without the complexity of articulation, making it simpler to maintain than the Big Boy or Allegheny. Its maximum tractive effort was a jaw-dropping 600 pounds-force. It was, in fact, the largest rigid-frame locomotive built on the PRR, and its sheer physical dimensions and power output placed it firmly in the category of the world's largest. The engine's design pushed the limits of what a non-articulated locomotive could achieve in terms of boiler size and resulting power. Serving predominantly during the high-demand wartime era, the Q2s were exceptionally powerful and fast, capable of hauling heavy trains at high mainline speeds. Unfortunately, the Q2s had a relatively brief career. Their complexity and the rapid post-war shift to diesel power meant their operational life was cut short. Nonetheless, the Q2 remains a towering example of a late-steam-era rigid-frame monster, a final great push by the PRR to maximize performance before the steam era's end. When we look at British steam, the definition of largest shifts to a focus on maximizing power and size within the nation's notoriously restrictive loading gauge, the tight tunnel and bridge clearances. The British Railways Class 9F was the ultimate expression of this constraint, arguably the largest and most powerful standard gauge conventional locomotive ever built in the UK, an absolute workhorse. Designed in the 1950s, the 9F was a massive 210 freight engine, a configuration that delivered exceptional pulling power. Its great size was dictated by its deep, wide firebox and large boiler, all squeezed meticulously within the narrow British clearance limits. It was the epitome of British standardization, designed to handle the heaviest freight traffic on any line in the country. To maximize its limited size, it utilized a sophisticated system that enabled high boiler pressure and efficient steam generation, delivering over 39,000 pounds of tractive effort. The Class 9F entered service late in the steam era but quickly became legendary for its reliability and immense strength. It was the final, highly advanced design produced by British Railways. Famously, one member of the class, Evening Star, was the last steam locomotive ever built for British Railways. Despite its primary role as a freight engine, the 9F proved surprisingly capable of high-speed running, with one unit unofficially recording over 90 mph. Its size is a testament to the skill of British engineers to pack such immense power into a physically constrained machine. The Southern Pacific GS4 represents the pinnacle of large, high-speed passenger locomotives, prioritizing speed and aesthetic size alongside power. These locomotives were the visual signature of the daylight passenger trains, running along the scenic California coast, a route that demanded both immense speed and an equally massive presence. The GS4, with its 4/8 wheel arrangement, was a huge locomotive designed for sustained high-speed operations. Its size was necessary to carry the large boiler required to maintain steam for long, continuous runs at speeds often exceeding 75 miles per hour. A defining feature, besides its iconic orange and red daylight livery, was the massive streamlined shroud that covered the boiler, making the engine look even more colossal and imposing. This engine was not merely large, it was styled to be large, conveying speed and luxury. These engines were the absolute celebrities of the Southern Pacific lines, hauling the famed Coast Daylight and other important passenger trains. Their reliability and speed were critical to maintaining the tight schedules of these prestigious services. With a total weight of approximately 437 short tons and a tractive effort of over 73,000 pounds-force, the GS4's massive physical size, combined with its high-speed capability and legendary status, cemented its place as one of the largest and most recognizable passenger engines in history. The German DR Class 45 stands as the largest standardized freight steam locomotive ever built in Germany, and indeed one of the largest conventional engines in all of Europe. Designed just before the outbreak of World War II, it was intended to replace existing heavy freight locomotives and provide the colossal power needed for the rapidly expanding German industrial rail network. The Class 45 featured the 210 wheel arrangement, chosen specifically for its phenomenal tractive effort, making it a genuine powerhouse. Its size was a direct result of housing the largest boiler ever built into a German standard gauge engine. This massive boiler was required to produce the necessary steam for sustained, slow-speed, heavy hauling. The sheer dimensions, with a length of nearly 78 feet, and the enormous boiler diameter put it near the limit of the European loading gauge, marking it as a truly gigantic machine for its operating environment. Its tractive effort was a respectable 58,000 pounds-force. These locomotives were the backbone of heavy freight traffic, especially during the wartime period when maximizing train loads was critical. Despite initial issues with boiler materials, the Class 45 proved its worth as a formidable haulage engine. Its legacy is one of pure, unadulterated strength, demonstrating how European engineers maximized conventional design to achieve colossal size and pulling capability, competing in scale with many American designs. Finally, we look at a different kind of giant, the articulated Garratt locomotive. The New South Wales Railways NSWGR Garratt 70 class was arguably the largest of its type designed for general service in Australia. The Garratt design inherently creates a visually and physically enormous machine by splitting the boiler between two separate engine units connected by an immense frame. The 70 class, with its 484 plus 484 wheel arrangement, featured two complete 484 engine units. This unique articulation allowed for incredible flexibility on tight curves and critically distributed the immense weight over more axles, reducing the axle load and making it suitable for lighter track infrastructure common in colonial and developing railway networks. Its total length reached approximately 108 feet, and its maximum tractive effort was nearly 60,000 pounds-force. Its length and overall mass made it a monster on the rails, designed to traverse long, challenging routes with minimal track damage. The 70 class was an essential tool for hauling heavy coal and wheat trains across the challenging terrain of New South Wales. While their service life was relatively short due to operational costs, they demonstrated the massive potential of the Garrett design. The sheer sprawling length of the 70 class Garrett makes it one of the most physically large locomotives in this list, a true titan that proves size can also be incredibly flexible. We have reviewed the giants, from America's colossal big boy and powerful Allegheny H8 to the unique engineering feats of Germany, Russia, and South Africa. These machines represent the undisputed apex of the age of steam. But the debate is never truly over. Which of these behemoths truly deserves the title of the greatest? Comment below right now and let us know your vote. If you were amazed, hit subscribe. We'll see you on the rails.